after the discussion of this 5-step method, we had discussed these examples. We had calculated what is the mass of CO2. So in first step, you will write equation. I told you your equation, and balanced chemical equation will be present in your question or anywhere in your book. In third step, you will change gram to mole, then mole ratio method, and then mole to gram. So that is your answer. Simple calculations. Okay. So after that, we had discussed this example. And after that, we had discussed limiting reagent, and we had discussed this example. We had discussed this part, first A and B part, how to calculate limiting reactant. And this part is remaining. So we shall discuss this part, but let me explain this part again. I told you if we have one sandwich, or you can say it's a burger. So there are two pieces of bread. So how many breads in one burger? Two. And how, suppose we can say a piece of meat or piece of chicken. Let's have chicken piece. So one chicken piece and two pieces of bread make one burger. Is it? If I take 10 breads, 10 pieces of bread, how many burgers you can make? Yes, you can say.
Five.
Very good. 5 burgers. Excellent. If I take 3 pieces of chicken, how many burgers you can make?
3.
3. Very good. Okay. If I take, now let's discuss our reaction. When bread reacts with or attach with chicken pieces, then burger is formed. So if I take 10 breads with 3 chicken pieces, how many burgers you can make?
3.
Very good, 3. And how many breads are left?
7.
4.
6.
4.
4.
4.
How do you know? How do you know?
4.
How do you
Because
know?
we used 6 pieces of bread.
Very good. For making 3 burgers, you need 6 pieces of bread. So after utilizing 6 bread pieces, so 10 minus 6, then you will get 4. So 4 pieces of bread are in excess. Okay. Okay, friends, now come to our discussion. Let's do it again. Here we have a question. Question is, urea is prepared by using ammonia and carbon dioxide. Is it? Can you see this slide?
Yes.
Yes.
Okay, good.
Yes.
Okay, good. Okay, students, all students listen it carefully. Again, I am going to start, and don't use your mobiles. Okay, close your ears, close your doors. Now listen it carefully. Ammonia is prepared by using carbon dioxide. Sorry, urea is prepared. Okay. We have to find limiting reagent first. How can you find limiting reagent? We have ammonia, we have carbon dioxide. So first we will use 637.2 gram of ammonia to calculate amount of urea. Okay. Now, in the second question, we will use 1142 grams of carbon dioxide to calculate urea. Now, from these two, ammonia and carbon dioxide, which will give you smaller answer, that will be limiting reactant. Is it? Now,
Yes.
good. When you calculate from ammonia, Your answer is 1124 gram of urea by using 5 steps. When you use carbon dioxide, your answer is 1557 gram of urea. Okay. Now, which answer is smaller? This one, first one, or second one?
First one.
Ammonia.
First one. Very good. So, our first answer is ammonia is the limiting reactant because it gives you smaller answer. Is it?
Yes, yes.
Okay,
Yes.
very good. Very good. So, answer of first question is ammonia, NH3. So, okay. Now calculate the mass of urea formed. What is the actual mass? The first one or second one?
First one.
First one,
First one.
because after making 1124 gram of urea, this ammonia is finished. If ammonia is finished, to which compound this carbon dioxide will react? It will not react with any ammonia because we don't have ammonia. So it means our reaction will stop at 1124 gram of urea. So 1124 gram of urea is actually produced. This is the answer of second question. Yes, young man.
Sorry, Doctor, I have question in B.
Yes, yes.
The answer in B is same as reagent.
Yes, always.
Always.
Yes, always. Boys, it is very simple. It is very simple. If you have finished one thing, how can you produce more product? Look, you are suppose you are making tea, okay, with caffeine and milk. If you have finished milk, can you make more tea? No, you cannot. If you have finished one thing, you cannot make another thing more extra. No, because we have finished ammonia. If you have finished ammonia, it means reaction will stop after the production of this urea. It will stop it here. It will not prepare this amount of urea. Okay, because we have finished ammonia. So actual amount of urea is 1124 gram. Is it?
Yes, yes.
Yes.
Okay. Now this is actual amount. Now we now come to the third part. How much excess reagent in grams is left at the end of reaction? Okay. Now when this ammonia will finish, this carbon dioxide is in excess. It is more. So how much more carbon dioxide is left behind? How much more carbon dioxide is present there? How can you calculate? Now tell me, how can you calculate? Okay, now stop it here.
Correct
I
what,
give
Doctor?
amount of carbon dioxide. Okay, leave it. Don't go to this step number 3. Sorry, third part of this question. Come back to our again same burger and chicken. Okay, we have 2 breads in one burger and one chicken piece here. Now listen it carefully. Now I know you already know this one. If we have 10 breads, we can make 5 burgers. If we have 4 chicken pieces, how many burgers you can make? 4 burgers. Okay, very good. Now, if I make a reaction with bread and chicken, then it will form, it gives us burger. Okay, now, if I take 10 breads and 4 chicken pieces, how many burgers I can make?
4.
4. Now 10 breads can give us 5 burgers and 4 chicken pieces give 4 burger. Now these chicken pieces This chicken is a limiting reagent. Why? Because it gives a smaller answer. Okay. Now we get four burgers. That's good. My question is, how many bread pieces are left behind?
6.
6.
Why?
Two, two.
No, no,
Because
2, 2, Doctor, 2.
yes. In four chicken pieces, you use 8 breads. Okay. Now then you make 4 burgers. It means, in other words, now come back to this one. From 4 burgers, how many breads are used? Now tell me, how many breads are used?
8.
8.
8.
How many breads are left behind?
2.
2. 2. Because what you did, listen it in your
Use
mind. Listen it carefully. Listen and think it in your mind. You have calculated these 4 burgers can be made from these 8 breads. It means 4 burgers can be made from 8 breads. How many extra breads are left? 10 minus 8. Then you
Yes.
will get this 2. Is it?
Is it?
Yes,
Yes.
yes.
Good.
Yes, yes.
Now what will you do? Now you will think 1124 gram of urea is prepared. How much carbon dioxide is used? Same thing with 4 to 8. Okay. Now problem is these burgers are eatables. You like these burgers, but you don't like this bread and this urea and carbon dioxide.
Doctor,
Yes.
1124 grams of
Urea. This is urea.
yes, urea used by
Now,
or
how much
what?
carbon dioxide? How much carbon dioxide? So you have to calculate this carbon dioxide now. How will you calculate? By using 5-step method. Okay.
Use 1124.
Okay. Now you use 1124 gram of urea. Multiply, divide,
Okay, small.
multiply and divide. Change gram to mole. First gram of urea down, and here mole of urea up, and here in one with mole and with urea 60 gram because molar
60.
mass of urea. In mole ratio method, I told you what is malum now. What is given? Urea. Urea is given
Yes.
1124 gram. But check from the from here, from this equation. How many moles here?
1 and 1.
1 and 1. So urea, urea malum. So you will use urea 1 mole of urea, and here 1 mole of
Dioxide.
carbon
Carbon
dioxide.
dioxide.
Okay, when you change mole to gram, you will write mole of carbon dioxide down and gram of carbon dioxide up. 1 with mole and 44 with gram.
Yes.
Okay, now use calculator. Simple. Now you see gram of urea cancel, mole of urea cancel, mole of carbon dioxide cancel. When you use calculator, 1124 multiplied by 44 divided by 60. What is your answer?
824.
24 gram of carbon dioxide. Is it?
1, 3.
0.3. 824.3. Okay, no problem. We can write. Okay. Now, by
Doctor,
making no, listen it carefully. By making 1124 gram of urea, look, by making this urea, how much carbon dioxide gas is used? 824.3. It is actually used. It is just like 8.
Yes. Minus.
Now how much is excess? 1100. This amount, this is same like 10 minus 8. So it is
Yes.
1142 gram minus 824.3. What is your answer? What's your answer, boys? It is 317.
300.
317.7.
Seven.
Is it?
Yes.
7 gram of CO2. Now this is the answer of third question. Yes, young man. Now any question?
You mean that 824 of carbon dioxide react with 637.2
0.2
grams
gram of
of
ammonia. Very good. Yes, yes, yes.
produce 1124 of
Urea. Very good. Yes.
okay.
Okay, all other students, boys, it's okay.
Yes, it's clear.
Okay, mashallah, it's clear. Okay. Okay, friends. Now our next topic is reaction yield. Now I will finish this one. We have last 10 minutes. Inshallah, we will finish. What is reaction yield? What is yield? Yield means quantity. Quantity. So quantity of substance during reaction is known as reaction yield. Miqdar. Quantity miqdar. Okay. Now we have two types of reaction yield. Two types. One is theoretical yield. One is actual yield. Theoretical yield and actual yield. Okay, friends, what is theoretical yield? Well, when you calculate your answer after the calculation from a balanced chemical equation, when you solve your question on the paper and you get your answer is the theoretical yield. Theoretical yield. So the answer, the amount of product. Now, how many grams of urea is obtained? 1124. How did you get? After calculation. So the
11.
amount, yes, after calculation, your answer is theoretical yield. Theoretical yield. When you solve your question and you get the answer, this amount is known as theoretical yield. Clear this one?
Clear.
Okay.
Yes.
Now, second type is actual yield. Boys, when you prepare something in a laboratory, after your experiment, that amount which is obtained in the lab, in chemistry lab, after the reaction, that is known as actual yield. Actual yield. Okay. Now, first thing you calculate on the paper, and after that you go to lab and perform reaction. Now, the amount that is obtained after the experiment is known as actual yield. Clear this one?
Yes,
And
it's clear.
this actual yield is always obtained after experiment, after reaction. And this theoretical yield is obtained after the calculation on the paper. Okay. Okay, friends, now what will you do here? You should know the difference between these two yields. Now, usually we write percent yield. Percent yield. Yes, any question, boys? Okay. Okay, friends. Now, we write our answer in percent yield. All chemists in the world, we usually, when we perform these calculations and reaction, then we write our answer in percent yield. So what is the formula percent yield? Actual yield divided by theoretical yield multiplied by 100. So your answer will be in percent yield. Now, oh, mashallah, it is already written here. Okay. Okay, friends. Now, how to get this percent yield? Here is a question. Titanium is a strong, lightweight, corrosion resistant metal. Okay. That is used in rockets, aircraft, jet engines, and bicycle frames. Okay. It is prepared by the reaction. Okay. We have a reaction. What is the question? In a certain industrial operation, 3.54 into 10 to the raised power 7 gram of titanium chloride are reacted with 1.13 into 10 to the raised power 7 grams of magnesium. Calculate the theoretical yield of titanium. You have to calculate titanium now. What is given? Titanium chloride and magnesium both. And second part is calculate the percent yield if 7.91 into 10 to the raised power 6 grams of titanium are actually obtained. This is actual yield. Okay, now let's calculate theoretical yield of titanium. How can we calculate? We are given titanium chloride, we are given magnesium. So we use both. How? What is
Change
given?
small.
Very good. So it is same 5-step method. Now you see this method is importance of this method, that is titanium chloride. When it reacts with magnesium, it gives us magnesium chloride plus titanium. Is it? Here it is. Now we have to calculate titanium. Right equation is there. Balance this equation. Yes, it is already balanced. Now third step, change gram to mole, then mole ratio, then mole to gram. Okay, let's start with titanium chloride. How much titanium chloride is given? 3.54. 6 or 7 gram of titanium chloride. This is our first part. And second part is 1.13 into 10 to the raised power 7 gram of magnesium. Okay, friends, now we will use these two quantities in 5 steps. So step number 3, change gram to mole, mole ratio method, and mole to gram. Okay, how? Change gram to mole, gram of titanium down and mole of titanium up. Titanium chloride. Okay, now next, here I am going to tell you one trick, very important. Now you will complete these questions within no time, whatever the question is given, whatever the question is. Okay, so listen it carefully. What is given here? Titanium chloride. It is given, write it down. What you have to calculate? Titanium, write grams of titanium here. Are you with me?
Yes.
Yes.
So listen it carefully, Here you will write opposite, gram to mole, mole of same compound, titanium chloride. And here mole of titanium. Now here you will write the same, mole of titanium here. And here you will write this same, mole of titanium chloride. Very simple. Now in step number 3, 1 with mole, and step number 5, 1 with mole. And with gram, molar mass. So what is the molar mass of titanium chloride? TiCl4. Titanium mass is 48. You can calculate. 48 plus 35.5 multiplied by 4. It is 71, 142, 148, 42, 190 gram. So 190.
190.
Yes?
190.
190. Good. And here titanium 48. And here in step number 4, I told you always use this equation. What is with the titanium? 1 mole. So write 1 with titanium. With the titanium chloride, how many moles?
Also
One.
one.
Mole of titanium cancel. Gram of titanium. Sorry, no, not a gram of titanium. Let me erase this. Here, mole of titanium cancel. Gram of titanium chloride cancel. So what is your answer? 3.5. 0. Astaghfirullah. La ya shabab. It is 8.97 into 10 to the raised power 6 gram of titanium. Is it?
Yes, yes.
Okay. Now, by using same method, okay, good. Use it, complete it. What will you write? Third step, fourth step, and fifth step. Okay. What will you write here? Gram of
Gram of
magnesium.
magnesium.
Here, what will you write? Gram of titanium. Because it is given and it is majhul, matloob. You have to calculate. Okay. Now, here change mole of magnesium and here mole of titanium. Opposite. Now, here same you will write it mole of titanium from this one. And here you will write mole of magnesium. Now, one with mole, with magnesium 24 and titanium 48 and mole of titanium here 1, mole of magnesium here how many?
2.
2. Very good. Okay, now what will you do? Gram of magnesium, mole of magnesium, mole of titanium cancel. When you use calculator, your answer will be 1.13 into 10 to the raised power 7 gram of titanium. You can use calculator. Even 24 multiplied by 2, 48 cancel. Answer will be same. Okay, students. Now we got two answers. 8.97 into 10 to the raised power 6 gram titanium and 1.13 into 10 to the raised power 7 gram of titanium. Now tell me, which is the correct answer?
First.
The first one,
Very
smaller one. Very good. Excellent. So this is your actual amount. Now, can I ask you one more question? Which of the following, which of these, titanium and magnesium, titanium chloride and magnesium, which is a limiting reactant?
Titanium.
Titanium chloride.
Titanium.
Excellent. Very
Chloride.
good. Okay. So what is your theoretical yield? This one. This is your answer. Your actual answer is your theoretical yield. So what is your actual yield? It is given in your question. Guys, remember, actual yield will be given in your question always. Okay. So 7.91 into 10 to the raised power 6 divided by theoretical yield 8.9.
8.97.
Very good. 6 multiplied by 100. What is your answer? It is 88.18. That is 88.2%. Boys, this is your percent yield. Now, any question?
I
Yes,
have
yeah.
question.
Yes.
7.9. How we get it?
It is given in your question. Very good question. Here, this one,
Always Victor.
actual yield will be given in your question. Boys, listen. How can you find actual yield in your exam? Will you go to the laboratory?
No.
Then, so it means actual yield will be given in your question, and theoretical yield you will calculate by yourself. How? By using these 5 steps. Very good. Excellent. Now, any other question? Okay. Okay, students. So this is our today's lecture, and we have finished our chapter number 3.